Hi there, folks. This is the Unit 9 review, and as always, I am the amazing Mr. Jansen, so away we go. As we look through these, remember we're going to be utilizing some of these formulas. Keep in mind that these guys right here are arithmetic formulas. This is for the term of an arithmetic sequence. This is for the sum of an arithmetic sequence. Down here, these are our geometric formulas. Again, this one's for the term. This one right here is for the sum. And this one's for the sum of an infinite geometric series. So if we look at the first one, it says find the next four terms of the arithmetic sequence. This is one that we don't need our formula for. We're just identifying the pattern, and the pattern here is that I'm subtracting 4 each time, or I'm adding a negative 4. So then I add a negative 4, and I just keep that pattern going. If I add a negative 4 again, it gives me a 9. If I add a negative 4 again, it gives me a 5. Add negative 4, add negative 4, and that's it. Okay, so I'm just adding negative 4 each time I come up with the next 4 terms. Okay? If I look at the next one, it says find the 13th term of the sequence. So I'm just looking for a term here, and I can tell that this one's arithmetic because of the D value. That gives away that it's arithmetic. And so I'm going to use my arithmetic formula, which is the a sub n equals a sub 1 plus n minus 1 times d. And I know I'm using this arithmetic formula because I'm not looking for a sum, I'm just looking for a term, and that's what this formula is for. And I plug in what I know. I know that a sub 1 is the 7, plus n is 13. It's the number of terms. It's how many terms I have, and it said right in the problem that it was 13. And then d is the thing I'm adding each time, which in this case is the 3. And so really I'm looking for a sub 13, and I just have to plug this into my calculator. When I plug this in, the 13 minus 1 is a 12, times 3 is a 36, plus the 7 is a 43. Okay, so I get a sub 13 equals the 43, and that's it. In the next one, it says to find the 4 arithmetic means between negative 6 and positive 9. And so really the situation I have is a negative 6, and then I have 4 blank spaces, and then the positive 9. And that's what arithmetic means are. It means I'm missing some terms in between. And so to get from term to term in an arithmetic sequence, all I need is the d value, and so that's what I want here. So I'm going to use my arithmetic formula, a sub n equals a sub 1 plus n minus 1 times d, and I'm just going to plug in what I know so that I can solve for d. And keep in mind, when we look at a sub n versus a sub 1, like a sub 1 is the first term, a sub n is the last term, so the first term here is the negative 6. The last term is the positive 9, so that's my a sub n. And then the n value is how many terms I have. Well, I count up, including the blank spaces, those terms I don't know what they are yet. When I count those up, I have a total of 6 terms here, so the n value is a 6. And I just have to simplify this and solve for n, solve for d. So here I've got a negative 6. Inside the parentheses, that gives me a 5, so I have 5d. And now I'm going to solve this thing. I'm going to add the 6 to each side. That gives me a 15. And then I divide each side by the 5. So I find out that d equals a 3. And that's great, but it's not done yet. D equaling 3 is wonderful, but what I want is what goes in the blank spaces. So I have to add that 3 a couple times. And so I do the negative 6 plus 3 is a negative 3, plus 3 is a 0, plus 3 is a 3, plus 3 is a 6. And then add the 3 one more time. It gives me a 9. And what that does is it confirms that I have the correct answer here. Okay? If I look at the next one, it says to find s sub n, so I'm looking for a sum this time. And I really just need to determine now if it's arithmetic or geometric. And the giveaway is the fact that there's a d value here. Even though the arithmetic formula doesn't use a d value, the presence of a d value is basically telling me that this thing is arithmetic. So I'm going to use my arithmetic sum formula, which is s sub n equals n over 2 times a sub 1 plus a sub n. Okay, so I need the first term, the last term, and then the number of terms that I have. So I just start plugging in what I know. I know the number of terms I have. I know n is the 20, so that means I'm looking for s sub 20. I know a sub 1 is the 7, but a sub n, the last term, I don't know what the last term is. And whenever I'm doing a series or a sum here, if I'm missing a term, I just need to go back to the previous formula. And this is why I needed the d value. I need to go back to this formula to find out what a sub n equals. So I start plugging in what I know. I know a sub 1 is the 7. I know n is the 20. And I know that D this time is an 11. All right, so really I'm looking for A sub 20. But now again, I just plug this into my calculator. And when I plug this one in, it looks like it gives me a 216. So now I have my A sub n. I plug that in over here. That's the 216. And now this is, again, a job for my calculator. So I just start plugging this stuff in. And when I do, it looks like this gives me a 2,230. And that's it. All right, so we start with our sum formula because that's what it asked for. And then if we're missing something, we go to the previous formula. Okay? The next one says to find the sum of the arithmetic series. I know it's arithmetic because the problem said it was arithmetic, but beyond that, I can see the pattern here is that I'm subtracting 2 each time or adding a negative 2. So I'm adding negative 2, and then I'm adding a negative 2, and then adding a negative 2. Okay, so the pattern is that I'm adding a negative 2, and that just looks ugly, so I'm just going to get rid of it. So really what that's telling me now is that my D value here is a negative 2. That's what I'm adding each time. All right, so I just start plugging what I know. I want the sum, so I do S sub n equals n over 2 times a sub 1 plus a sub n. And I don't really need the D value for this formula, but as I look around, I start to plug things in. I have a sub 1, that's 13, that's the first term. A sub n is the last term, that's the negative 25. But I don't know how many terms I have, because remember that this dot, dot, dot in between here, that means there could be, one term in between there. There could be 100 terms in between there. I simply don't know. So what happens here is I need to go to my other formula in order to find the n value. All right? So I go to my other formula, my a sub n equals a sub 1 plus n minus 1 times d. That is a really bad looking parenthesis there. I can't live with it. Gotta fix it. And now I plug in what I know. I know a sub 1 is the first term, that's 13. A sub n is the last term, that's a negative 25. N is the thing I'm looking for. And the pattern was I was subtracting 2 each time or adding a negative 2. That's my D value, is the negative 2. All right? And now from here I'm going to solve this thing. There's a couple different ways that I can solve this. I'm going to distribute first, because I feel like this is the most common way to do it. So I distribute that negative 2. And now I'm going to combine like terms. It gives me a negative 25 equals negative 2n plus 15. And now I'm going to go ahead and solve the equation that's left. I'm going to subtract the 15 from each side. So here I get a negative 40 equals a negative 2n. And now I divide each side by the negative 2. And the really nice thing about solving for n is you know that n has to be a natural number. It can't be a negative, it can't be a decimal, it can't be a fraction, okay? So now this kind of helps me confirm that that n value should be correct. And now I plug it back in over here, so I plug my 20 in. So now I know that I'm looking for S sub 20. And once again, this becomes a job for my calculator, although this one you could probably do in your head. Looks like a negative 120. Okay, that 0 looks like a 6. Let me try again. There we go. Okay, in fact, this 0 down here also looks like a 6. There we go, making it look good. Making it look good, Mr. Jansen. If I look at this one, it says to find the, well, it just says to find. And really, we should know what this thing is asking for based on the notation. This Greek letter right here, sigma, indicates that we're going to do a sum. So this is essentially going to be a series. You could use a formula for this, but you really only need the formula if we're going to a value that we're not willing to plug that many values in. Since here we're going from 1 to 5, that means we're only going to have 5 terms. I would just write all of them out, okay? So it's telling me to start down here with a 1, so I plug a 1 in first. So when I plug a 1 in, it looks like it gives me a negative 7. And then I plug a 2 in, that gives me a negative 5, and then a 3, it's a negative 3, a 4, and then when I plug a 5 in, it gives me a 1. And that's where I stop, and I stop there because there's a 5 up here. That's where that tells me which n value to stop at. So now I have all these. Sigma's just telling me to add these things together. So I add them up. It looks like it gives me a negative 15, and that's it. Okay, so sigma means, hey, take this thing, find the terms that it's asking for. In this case, it was 1 to 5, and then add them together. For the next one, it says to find the next 2 terms. Again, if we're just looking for immediate terms after the ones we already have, there's no need for a formula here. For this one, we just need to figure out if it's arithmetic or geometric. This one's not arithmetic. I'm not adding the same thing each time. That should be obvious. But it is geometric, and it might be difficult to find out what you're multiplying by here. The easiest way to do that, remember the shortcut here, is if you have like 10 times something, we'll call it r, equals the next term. I want to know 10 times what will equal 4. Well, I can just solve this for r and divide each side by 10. And what I'll find out is r, the thing I'm multiplying by, is 4/10 or 2/5. Okay? And now from here, I can just use my ability to work with fractions. If I multiply by 2/5, gives me the next term. That's a 16/25. And then if I multiply that by 2/5, it's going to give me a 32/125. Okay? And obviously, I could use my calculator for that, but really, what's the point? So my next two terms were the 16/25 and the 32/125. Okay? If we look at the next one, it says to find the fifth term given a sub 1 and given an r value. So right away, because we're given an r value here, we know we're looking for something that's geometric. And so since I'm looking for a term here, not a sum, I'm going to use my geometric formula that says a sub n equals a sub 1 times r to the n minus 1. And I just start plugging in what I know. I know that a sub 1 is the 1,458. I know that the r value this time is a 2/3, and I'm going to raise it to the 5 minus first power here. Okay, and so what I do here is I go ahead and I just plug this right into my calculator, and I want to keep this as a fraction. Hopefully it doesn't come out as a decimal, but I just plug it in and see what I get. So when I do that, it looks like it gives me a 288, and that's it. So this one worked out well. It didn't give me a decimal or a fraction to begin with. So you just plug that in and see what you get. If you do happen to come out with a decimal, try to rewrite it as a fraction. Okay. If I look at the next one, it's asking for us to find the 4 geometric means between these. So if I've got a 7 and then I have 4 geometric means, so I have 4 blank spaces here, and then the 224. And really, since it's geometric, for a geometric sequence to get from term to term, I just have to simply find the r value. So I need the thing that I'm multiplying by each time. So I'm going to take my formula, my a sub n equals a sub 1 times r to the n minus 1. And I just plug in what I know. Remember, a sub 1 is the first term, that's a 7. A sub n is the last term, that's the 224. The r value is the thing I'm looking for. And now I just have to raise this to the n minus 1. Well, n is how many terms we have, including the ones that I don't know what they are yet. There are 6 terms here, so that's 6 minus 1. And now I just have to solve this thing, so I'm going to divide each side by the 7. When I do that, that's going to give me a 32 equals r to the 5th. And now I just have to take the 5th root of each side. After I take the 5th root of each side, and to do that, on my calculator, I can use the x root button. You got to punch in the 5, then the x root button, then the 32. Or you can do 32 to the 1/5 power. Or you can use your brain and just say r equals a 2 here, because 2 to the 5th power is a 32. But now that's not good enough. I'm not done yet. It's great to have the r value, but what I want is what goes in the blank. So I do the 7 times 2 gives me a 14, times 2 is a 28, times 2 is a 56, times 2 is a 112, and then do times 2 one more time, and you get to 224. So now I know that I've done this correctly. Okay? If I look at the next one, it says to find the sum of the geometric series to 6 terms. So now I know I'm looking for a sum, and I know it's geometric, so I use my geometric sum formula, which is s sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. And I just start plugging in what I know. I know that the a sub 1 value here, a sub 1 is the first term, which in this case is a 1/9. Let me bring that down here. So that's 1/9 times 1 minus r. Well, the r value, I just have to look at the pattern here. When I go from term to term, the pattern is that I'm multiplying by 3 each time, so my r value is a 3. So I put a 3 down here. N is how many terms I'm looking for. Well, I'm going to the 6th term, sorry. Let me try that again. So the 6th term, all over 1 minus r, which was a 3. So now I'm looking for s sub 6. And really, again, this is just a job for my calculator, so I just plug it in. And when I do that, it looks like it gives me a 40.444444, and that 4 just keeps going, which is really 40.4 repeating. And this is absolutely one that we should write as a fraction or a mixed number. Probably a mixed number would be easiest. And there's no excuse to leave this one as a decimal, because I know the 40 part is just 40. And then the 0.4 repeating forever, this is something we learned in this unit. 0.4 repeating forever is 4 over 9, okay, using my shortcut. So this is 40 and 4/9. And that's probably the way I should leave my answer, okay? The next one, it says to find the value here. And again, this is sigma notation, which means that I'm just finding a sum, and it's telling me to start with a 1 and keep going till I get to 4. So I'm going to plug a 1 in. When I plug a 1 in here, it gives me a 6. When I plug a 2 in, it gives me a 12. When I plug a 3 in, it gives me a 24. When I plug a 4 in, it gives me a 48. And I know that I'm adding those together because that's what the symbol sigma means. It means add these things together. And so I add them up, and it looks like this one gives me a 90 when it's all said and done. Okay? And again, we could use our formula for that one, but it doesn't make sense to use the formula when it's easy enough just to write out the 4 terms and then add them together. Okay? So you have to decide when a certain list of terms would be too many to write out. Okay? This next one asks me to find a sub 1 given s sub n equals 105, r equals -2, and n equals 6. And the giveaway as to which formula I should use here is given in 2 parts. The first part is the fact that this says s sub n, so I know that I have to use one of my summation formulas. And then the fact that I'm given an r value means it has to be the geometric formula, which means the formula I have to use is s sub n equals a sub 1 times 1 minus r raised to the n all over 1 minus r. And really, I'm just plugging in what I know. I know the sum is 105. A sub 1 is the thing I'm looking for. 1 minus r is going to be a -2 raised to the 6th power. That's what n is. All over 1 minus r, which is a -2. And you just have to be really careful. The temptation that folks have is right here. They want to change that subtracting a negative to adding the opposite. But you can't do that, because you have to take care of this exponent first. Okay, so we have to do that exponent first to simplify this thing. And when we do, see, we end up with 105 equals, we get a sub 1, 1 minus, when I do -2 to the 6th power, that negative gets taken care of right here when I raise it to the 6th power and get a 64. Okay, so that's why I really have to make sure I don't do subtracting as adding the opposite till after I do the exponent. I have to follow order of operations there. In the denominator, I can't change this guy to adding the opposite because there's nothing else going on here, so that's going to give me a 3. And then from here I have 105 equals a sub 1 times a -63 divided by 3. And then I could simplify this further. I could divide these. The -63 divided by 3 is going to give me a -21. So I have -21 times a sub 1. I just have to divide each side by the -21. Okay? So this is a seemingly very complex problem because we haven't done anything exactly like this. But it ends up being very, very simple. You're just plugging in some values and then doing a little bit of simplifying and then solving. And when I divide that out of there, it looks like it's going to give me a -5. And that's it. For this one, it says find the sum of the infinite geometric series if it exists. So remember, these are the ones where I want to use this formula s equals a sub 1 over 1 minus r, but I can only use that formula if my r value is between -1 and +1. So in this formula, r has to be between -1 and +1, okay? It's got to be a proper fraction. So I first have to identify my r value. When I go from term to term here, it looks like I'm multiplying by 3/2. So my r value this time is 3/2, which 3/2 does not fall into the acceptable range. It's not between -1 and +1. So I say that this sum does not exist. So I'll write DNE for does not exist. Or you can just say it diverges. Okay, that's another way of saying that this thing is not going to be a specific value. It's going to diverge. So it's going to go to infinity in some way, shape, or form. Okay. If I look at the next one, it's the same thing. I'm going from 1 to infinity here, so I go from 1 to infinity. So really, I've got an infinite geometric series. So I look at the r value. Well, here this is in the format of a geometric sequence. So I've got that kind of formula. This is my r value right here. This is my a sub 1 value. And so the r value is 3/2, which is in the acceptable range. So I do s equals, that's going to be a sub 1, which is the 12 over 1 minus 3. Sorry, 3/5. I think I said 3/2 earlier, but 3/5. And so now it's just a matter of plugging away here. 1 minus 3/5 is going to be a 2/5. And now dividing by a fraction is the same as multiplying by the reciprocal. So instead of having 12 divided by 2/5, I'm going to have 12 times 5/2. And now from here, I just need to simplify. And I'm going to do this one by hand just because I can. And multiply straight across, that's a 30. Okay, so when I take an infinite number of numbers here and add them together, it's going to give me a 30 this time. And then the last one we have here, writing this as a fraction. We could write this as a geometric series, and we've done that before, and that's kind of why it's in this unit. But we found out very quickly that there's a great shortcut we can use here. Since the entire decimal is being repeated here, that bar is over the entire decimal, I can just take the two values that are being repeated and I put the number of values over that many nines. If it's one value being repeated, I put it over 9. If it's two values being repeated, I put it over 99. But if it's three values, I put it over 999. Four values, 9,999. So this one is two values being repeated, so I put it over two nines. And now I just have to make sure that I simplify the fraction. Each of these is divisible by 3. When I divide the numerator by 3, it gives me a 14. When I divide the denominator by 3, it gives me a 33. And also, feel free to check this on the calculator. Do the 14 divided by 33, and it'll give you 0.424242, and then you'll know that you've done this correctly. Okay?